So this week we've been talking about sound waves. And of course, you hear sound waves anytime you listen to music. When you're listening to a song and you hear different beats occurring in that song, that's because there are sound waves of different frequencies all combined together in that song. When sound waves of different frequencies meet up with one another, they interfere with each other. Recall there are two types of wave interference, destructive and constructive. So let's take a look at this graph of wave one. What this shows is sound waves in a song that have been recorded on an oscilloscope to make them more visible. So there's two waves of different frequencies. One wave is dark blue, the other wave is light blue. And these areas that are shaded in purple represent what happens when those two waves meet. So remember that destructive wave interference happens when one wave, the peak of one wave, like for example, this here for the dark blue wave, meets up with the trough of another wave, in this case the light blue wave. And the effect is the waves are out of phase, and so the combined effect is that they end up canceling each other out. So notice there's a significant reduction in the amplitude of the waves here, and actually right here at this point, they're canceling each other out to zero, where they actually meet. A little bit further along the oscilloscope, the crest of the light blue wave and the crest of the dark blue wave meet and pass each other on the same side of the origin. These waves are in phase. And so what happens is constructive interference, and this is where you see an increase in the amplitude of the wave as the two waves pass one another. They actually reinforce each other. So when you're listening to a song and you hear an increase in the volume of the beats, that's because the waves of two different frequencies are meeting up and interfering with each other constructively, reinforcing one another. When you hear beats in a song and the volume is starting to get a little bit softer, that's because waves of different frequencies in that song are interfering with each other destructively and actually resulting in a decrease in amplitude or a decrease in volume as they start to cancel each other out. So if we were to analyze this whole wave pattern, we would notice that this first sequence shows destructive wave interference as the amplitudes get smaller. Here in the middle, constructive as the amplitudes increase. Again, here, destructive as the amplitudes decrease. And here again, constructive as the amplitude increases. So what I'd like you to do now is take a look at wave number two, which is a little more complicated, a little faster tempoed as indicated by the different sections here. These would be all the different beats in your song. So I would like you to go ahead and label which parts of these sound waves represent constructive wave interference and which parts represent destructive wave interference.